consecutive? Yes.
Exterior, by the way.
Okay, they are consecutive exterior. Is that one of the theorems that we looked at?
No.
No, I think we only looked at consecutive interior. Okay? So, consecutive exterior is a great way to describe it, but that is not one of the theorems. Yo, what are y'all talking about?
I don't know.
No, he has both of the papers out he needs. Alright, stop. Pay attention. Okay. So, what might we think about those angles? First off, consecutive interior, were those supplementary or congruent?
Congruent.
I see people looking at me and saying it with a questioning tone. What could we look at to make sure we have it right?
I would supplement.
Okay?
No.
So once again, I see Jalen, I see Matthew with it out. We should have out this sheet as a reference point. Josh has it out as well. This is what we want to pay attention to. These are our notes to help us understand what we are practicing. You don't just pull it out of nowhere. All right. So consecutive interior supplementary, meaning they add up to what? 180. What do you think might be true about these two angles? They might add up to 180?
Yeah.
Now, but there's no theorem to prove that, correct?
Nope.
Okay, let me ask you this question. If I name this angle 1 and this angle 2, what do you know about those two angles? Okay, let's raise our hands so that we can share, because I heard a couple people say a couple of different things I think are accurate. Rose, what were you saying? They can translate, is the word I was looking for. That is true, because they are what type, well, and that tells us they are what type of angles?
They could go.
So they're corresponding angles, so they're not the same thing. Corresponding angles are congruent, but not all congruent angles are corresponding. Look. Pay attention, this is important. Okay, angles 2 and 3, are those congruent?
Yes.
Yes. Are they corresponding?
No.
No.
Yeah, sure.
Yes, because they're alternate interior.
Yeah.
So, it is important to recognize corresponding angles are always congruent, but not all congruent angles are corresponding. In fact, I could draw this angle, but look. I'm sorry you feel this way. Okay, these two angles, are there even parallel lines right now?
No.
No, but I've already told you they're congruent. Congruency can happen in lots of different cases. We just proved that corresponding angles are congruent, right? So corresponding angles are always congruent. Okay, so here's something I want you to think about. If these are corresponding and they are congruent, what do I know the angle or the measure of this angle is?
They're the same.
Same as what?
Same as 1.
Same as 1, which is?
2x minus 3.
Okay. Right? This angle and this angle are corresponding angles, so they are congruent. We good with that idea? Josh, you look like you're confused and unhappy with that statement. Are you good with the fact that these two angles are congruent, or are corresponding, so they're congruent?
Sure.
It's not a sure kind of question. Yes, you are, emphatically. You understand?
Yes.
Cool. It's okay to not understand, I just can't have a sure. A sure means, don't talk to me, Mr. Kinney, because I'm not actually sure, but I don't want to say I'm not sure. If you're not sure, I can work with that. Okay. So, Ari, what kind of angles are these two angles now? Because I know you're capable. That's cool. I'm tired too, but I'm still doing my best to learn. We got to push through the pain. All right, come on. What do we know about those two angles? Okay, one of them is acute, one of them is obtuse. There's more to it that we should know. Why do you think they're supplementary? A linear pair? Hey, all linear pairs are supplementary, right? We should know that. That's one of the homework things that we have to do tomorrow on the tan sheet. Okay? All linear pairs are supplementary. So what do we know about 3x plus 2x minus 30?
That they're equal to, linear.
They are linear pairs. Be careful about the language. It's not, they add up to be what? 180. Right? So these are a linear pair. But I need you to notice, we didn't know they were a linear pair at first, did we? What did we have to use to figure out they were a linear pair? We'll work on more about that in a second, Ireland. I need you to focus on this detail for now. I know. You're focusing on this. I need you to focus on this. Why did I know this was 2x minus 30?
Because
Because it's
it's congruent.
It's saying.
It's still there.
That does not say 2x minus 30. How did I know this was 2x minus 30?
Because it's congruent to 1 and then angle 1 and angle 2.
But okay, okay, stop. Hold on. Hold on. I need y'all to look at this. There was not a 1 or 2 there at first, Matthew.
Well, there you
I put a 1 and 2 to help us refer to it better, but this angle and this angle are what type of angles? I've heard congruent, but why do we know they're congruent?
Because they're exactly the same.
Raise your hand, because I have 3 people talking over each other right now. Ireland? Okay, and that's what Rose was referring to, but what type of angles can be translated on top of each other?
What's called? Shoot.
Corresponding.
Corresponding.
Correct. Rose, I need you to work on that. You are seeing the fact that they can be translated on top of each other. That's good, but you need to work on the language so they are corresponding. Okay? And so because they were corresponding, these were congruent. Alright, I'm going to pause there. I'm going to let y'all work on that when I release you in a second. Before we get there, alright, what relationships can we see in number 2 that might help us out?
Oh, they're same side interior.
Which ones?
8x minus 10 and 6y plus 20.
Okay, so we already know that those are same side interior. Austin, what do we know about same side or consecutive interior angles? Are they congruent or are they supplementary? We need to know they are what? Look at your sheet if you're not sure.
They're congruent.
And not congruent.
Do you have the sheet out in front of you?
That's the wrong.
This is not the right sheet.
What sheet is this? Corresponding to something.
If it says consecutive interior, what does it say on that sheet?
Same side.
Consecutive interior says they are.
Congruent. Transversal lines.
Say it louder. They're supplementary.
I'm being said that, bro.
Okay. So here's the thing. We have that 8x minus 10 plus what? 6y plus 20. If we add those together, what do we get? 180. That's supplementary. Boom. How many variables do I have there?
1,
2.
2. I can't solve that equation yet. I need to know one of those variables. Are there any other relationships that we can use? And so I might even make the note consecutive interior.
Subtract 6.
The 7x and what else?
7x.
Right here, 7x. Are there any angles that are related to 7x?
Yeah.
8x. Alternate exterior? I mean,
Okay.
interior option.
Are those alternate interior angles?
Yeah.
Are they on alternate sides of a transversal?
Yes, they
Are
inside the
they
parallel.
inside parallel lines? Yes. So they're alternate interior. So what do we know about those angles?
They're the same.
They are the same. They are
Congruent.
congruent. So their measures are
One. The same.
equal.
Yeah.
So 8x minus 10 and 7x are.
Equal.
Hey, can I solve that equation?
Yeah.
I hope so. This is why we cover that equations unit to start the year. We got to know how to solve stuff like this. So what would I do to solve that equation?
You do
plus 10, wait, no, add the combine like.
So I need y'all to pay attention because this is important. Can I combine those like terms?
No, because
There's that equal sign in the middle. I cannot put the 7x and 8x together. They're on different sides of the equation. So I need to make one of them a what?
Minus 8x.
So I'm trying to make it a what?
0.
0. Notice 8x minus 8x. That is
1. I mean 0.
0. Anything minus itself is always 0. Anything minus
Yeah, do it on the
itself.
other side too.
Okay, why do I need to do it to the other side?
Because you told us.
to make it
No.
equivalent.
To make it equivalent, you got to keep it the same. So whatever you do to one side, you got to do to the other.
-1.
Now, what is 0 minus 10?
Like
10.
Negative. No. It's negative.
So I need y'all. So
It's negative.
a lot of us are thinking negative 10, but I need to point this out. Hold on, because this was true both for you and my Algebra 2 kids. I had lots of students who had this, and then they told me it was negative 11x. And that just is not true.
Bruh.
What do you have available to you to figure out what this
Calculator.
calculator?
-10.
Use your calculators. Thank you. Okay, that is not negative 11x. Do your 0 minus 10, it's negative 10. Equals what?
Negative 1.
Negative.
How'd you figure that out, Matthew?
8 minus 0.
7 minus 8 in the calculator. Guys, use your calculators. So negative x. Am I done?
No.
What else do I need to do?
Divided by.
Divide by?
1, 2.
Remember, I want to solve for this
One.
x.
Or divided by 1.
It's a negative x, it's just negative 1. So x is equal to
10.
10. We go with that idea?
Yeah.
Now we use this next principle earlier over here. If x is equal to 10, what can I substitute 10 in for?
The X.
Now be careful, hold on. Listen,
7.
what can I substitute just the 10 in for?
X.
Not for 8x,
X.
just the x. That 10 can only be substituted in for x. Not for the 8x, just for the x. So it becomes 8 times what? 10.
Minus 10 plus 6y.
Now there are lots of ways to go from here. What is one step I could take?
Well, then multiply 8 minus 6.
Well, I don't have any parentheses, but could I do 8 times 10?
Yeah.
Multiply it to simplify it, so 80 minus 10.
That's wrong.
Okay, what can I do now?
80 minus 10.
Notice I can combine like terms. I'm not going to add 10. I saw a lot of students trying to add 10 on their midterm. But if I add 10 right here, can I do that? But where else do I need to add 10? To the other side of the equation. I don't recommend that, but I do want to point out, you can add 10, you would just then also have to add 10 over
So you
here.
wouldn't just do 80 minus 10?
No, that's what I would do. I'm just pointing out, if you are tempted to do this, because I then saw students do that. That is wrong. I'm actually adding 20 to the left-hand side now. If I add 10 to the left-hand side, I have to add 10 to the right-hand side. That's what I'm trying to point out. But yeah, I would just do 80 minus 10. What is that?
70.
Okay, next.
Then you do minus 20.
Okay.
On both sides.
Can I do minus 20?
Yes.
Is there anything else I could do?
Commutative? You can do plus,
Can't I use a commutative there to get my like terms together?
Huh?
Because now I would get what?
What?
90.
Right? And so I do want you to notice, right? Could I have subtracted 20? Yes. Would it have given me the same answer eventually?
Yes.
Yes. It's your preference. I just want you to see that this is what you can do.
Minus 90.
Minus 90, that's going to create a
0.
0. 6y is now equal to?
90.
And by the way, I know some of us are jumping there really quickly. If you're not jumping there really quickly, what can you use to help yourself out?
Calculator.
Oh, a calculator, right?
Video. What?
I need you to know how that I'm going to add or I'm going to subtract or I'm going to multiply or going to divide. As long as you can do that, you can use a calculator to finish solving it. Last step.
Y equals to, divide by 1 over.
Divide by 6.
And then equals 15.
Y is equal to 15. Hey, by the way, was that a lot of writing?
Yes.
Did that fit easily on that sheet of paper?
No.
So what could you do to make your life easier?
Get another sheet of
Oh,
paper.
get a blank sheet of paper out to write your stuff on, okay?
I know it.
I'm just trying to look out for you. We've got 30 minutes for you to practice this as much as possible on your own. We will finish this up tomorrow, but I need you to get as much done as possible in your small groups. Miss Mommy and I will be coming around. Well, you have to go soon, don't you?
Mom.
Okay? So, Miss Mommy will help us out for 10 minutes or so. I'll be here the whole rest of the time that we have, but let's get to work trying to solve for our variables. Finish up number 1. Yes, ma'am.